So today we're going to talk about the Big Bang Theory, which is the start of the universe. It's not something that you're going to agree or disagree with. If you have questions about the start, scientists are not sure what started the Big Bang Theory, but this is the leading theory on the beginning of the universe. So the universe started as nothing, and then all of a sudden we start to have this hot, very dense amount of matter all in this very, very tight space, and all of a sudden it just, for some unknown reason, starts expanding. And this is 12 to 14 billion years ago. Scientists have been able to recreate this in the lab, but how this dense matter got there, they're still unsure. The universe has been expanding ever since this point, and it's cooling from this hot temperature that it started with. The Big Bang event created all matter, energy, time, and space itself, but like I said, how and why, scientists are still not sure. And this is where you can bring in your other ideas about what created the universe. By dense, we're talking about smaller than the size of a pinhead, or the top of a paperclip. So all of this matter, energy, time, space was existing in this very, very small space. And then something happened. So this is where we have evidence to show a timeline of what happened after we have this Big Bang. So that small, dense, primordial fireball that is existing then starts to have this Big Bang and starts expanding. So 0 to 1 seconds after the Big Bang happens, our cosmos inflates and consists of electrons, quarks, and other particles. So we're starting to see the building blocks of our atoms, but we don't have everything yet. So quarks are what creates protons and neutrons, or what protons or neutrons consist of. And after the Big Bang, our cosmos is starting to rapidly cool, which is allowing these quarks to come together and create our protons and our neutrons. Now, 2 minutes after the Big Bang, we are still too hot for our atoms to form, so our protons, our electrons, our neutrons can't come together yet. We don't even have light shining. 3 to 7 minutes after the Big Bang, now our protons, our neutrons, and our electrons are going to start coming together. We've cooled down enough, and they're going to start what is called fusing together. Fusion means that they are coming together and building something bigger. We're going to talk about nuclear fusion and fission tomorrow. So our particles are going to begin to fuse together, and our protons, electrons, neutrons are going to come together. They're going to form hydrogen. Hydrogen is going to come together and make helium. And as they do this, and we've talked about binding energy that's holding our nucleus together, as we start to change that, we also release energy. So now on our cosmos timeline, we're talking about 17 minutes after the Big Bang. Our universe is cooled to where fusion could no longer occur, and our calculations predict the universe is 25% helium, and that 75% is hydrogen. And this is important because this is a piece of evidence for the Big Bang Theory, because, hey, guess what the universe is still made up of today? 25% helium and 75% hydrogen. 200 million to 1 billion years, our clouds of hydrogen and helium start to come together, and they're going to start creating galaxies and stars. In stars, that's where we can have even more elements created through fusion. So our helium can come together, and we're going to make our heavier elements like lithium, beryllium, boron, carbon, nitrogen, oxygen. We can go all the way up to iron in our fusion of stars. And this is kind of what we're looking at today for our universe. So now we've got our galaxies and our stars, and now they are formed, and our universe continues to expand. And we're going to talk about our evidence that shows that the universe is expanding. So all of science is based on evidence. So there's theories that have come before and after the Big Bang, but the Big Bang is the best theory based on the evidence that we have. Does that mean that the theory could change over time? Absolutely. As we have better technology, as we have more evidence that we're able to collect, it could be revised. But the Big Bang theory is the best theory that we have right now. And there's a video of Neil deGrasse Tyson talking about this evidence up on Google Classroom. So check that out after you're done watching the notes. So what is the evidence for the Big Bang theory? How do scientists come up with this? How do they justify it? Well, the Big Bang theory is testable. So we can create simulations very, very similar to the Big Bang in the lab, and scientists have been testing this for over 50 years. And these experiments are happening at CERN, which is where they have the large particle accelerators. They're able to have collision of particles. They're able to do these collisions at really, really close to the speed of light. And then they're able to see how these particles are interacting, and they're recreating very, very similar situations like those that existed right before the Big Bang. Another piece of evidence is the Hubble law. So Hubble's law shows that almost all galaxies are moving away from us, which supports an expanding universe. So the Big Bang happens, everything starts expanding, and we're still seeing that today. And Hubble's law is an equation that looks at the velocity of the galaxies is equal to Hubble's constant times the distance. And this is showing that all of the galaxies are moving away from one another. Another piece of evidence that shows that the galaxies are moving away from one another that backs up Hubble's law is the Doppler effect, which we talked about when we talked about sound. It's like the train whistle or the ambulance. And the Doppler effect is that apparent change in sound due to the motion So here you can hear it as a car is going to pass by us. The car is moving. So that drop in pitch that we hear is all due to the relative motion of the car and the waves being crunched as they're coming towards us. Because of the car coming towards us, the waves are going to get pushed closer together, and as the car passes by us, the waves tend to be spread out. Well, this is the same for the light waves that we are seeing with the galaxies. As things are moving towards us, they have what is called a blue shift, where the waves are closer together. And then as they're moving away from us, they have a red shift. So can you guess what the color of waves that we see from other galaxies are? Yep, it's red shifted. So this is another piece of evidence that the universe is expanding because of this Big Bang that we have. And then another piece of evidence is that black body cosmic microwave background radiation, which is leftover radiation from the beginning of the universe, and we can still detect this today. So after the Big Bang happens, we're going to have this leftover radiation, and it's not going to be in the form of visible light, it's in the form of microwave light. There were actually scientists that were looking for this background radiation, trying to find it. And then other scientists are also working on a project. They're looking out into space. They keep getting this annoying background disturbance in all of the things that they're finding. So they call the other scientists that are looking for this microwave background radiation, and they're like, we're getting this static in all of our experiments, how do we get rid of it? And the other scientists are like, you don't. You actually have evidence for the Big Bang. So this was kind of one of those accidental discoveries. That's an interesting story. But this background cosmic radiation tells us that, again, there was some big event that happened that released all this radiation out into the universe. So here's that Doppler effect that I was talking about. So our waves that are spread out are going to be red shifted. You can see them here. And this is what we're seeing in our universe. If everything was coming together or coming towards us, we're going to see this blue or violet because of our different wavelengths of our light. It's going to be the waves that are more crunched together, and we're going to see the violet because those wavelengths are closer together. And this video is up underneath the notes on Google Classroom. So if you want, you can pause the video and go watch it, or you can save it for the end and watch it with all the other videos. Up to you. So we talked about in our timeline that stuff had to cool in order to be able to come together. First element that's going to come together is going to be hydrogen with 1 proton, 1 neutron, 1 electron, maybe no neutrons, depending on the isotope. And then it's going to start fusing and becoming helium, and we had 75% hydrogen, 25% helium. Well, our helium percent in the universe should never go below 24 to 25%, and so far, all the evidence supports that the universe is roughly 24 to 25% helium. The sun and the stars also tell us about conditions a few minutes after the Big Bang. So because those elements were created a few minutes after the Big Bang, we can look to the sun and the stars as hints for what the universe was looking at. So there's a lot of scientists that are looking at stars and especially our sun. That's why it's such a big deal when we have solar eclipses, that scientists can get a better look at the sun, and we're going to talk about what's going on with our sun and stars tomorrow. And here's just a picture of what was happening in our timeline of the Big Bang. So we've got that dense starts expanding, starts cooling. As the cooling happens, we're going to start to have the creation of our first elements. As we get our protons, neutrons, and electrons as it's cooling, as those are able to come together, then we're going to start to have our galaxies created, our stars created, which is what is happening right in here. And then now we've got galaxies like we know, like the spiral, like the Milky Way, and now we have our present day. So you can see we're going from very dense, and then we're expanding outward, which you can see, and that's going to continue on and continue on until some unknown time. But again, all pieces that back up the Big Bang Theory, which is the leading theory until we get new evidence that shows us something else, but this is what all the evidence is pointing to right now. And if you've got other evidence and a theory that you want to talk about, we are open to that, but you've got to back it up with evidence and science. Most important thing. So now that you've filled out your notes, go ahead and watch some of the other videos. Once that's done, work on any other makeup work you need to turn in, and I will see you guys tomorrow.